In example number 4, he asks us to find the integration of negative 2x plus 4 over x squared plus 1 into x minus 1 squared into dx. Now, since we have x squared plus 1, we will use a fraction that has a numerator is ax plus b. And we have also x minus 1 to the power of 2. So we will use two fractions. The first one has the denominator x minus 1 and the second one has the denominator x minus 1 to the power of 2. Now find the like denominator and simplify the fractions to make it all of them on one fraction. We will multiply the first fraction by x minus 1 square in the numerator and denominator. We will multiply the second fraction by x squared plus 1 into x minus 1. And we will multiply the third fraction by x squared plus 1. Now, when we multiply ax by x minus 1 squared, it will be what? X squared minus 2x plus 1. It is identity. And also here, if we multiply and using FOIL property, we can find that the result is x cubed, x squared times x cubed, x squared times negative 1, negative x squared, and 1 times x plus x, 1 times negative 1 equal negative 1. By completing this operation, we can get that a plus c times x cubed plus negative 2a plus b minus c plus d x squared plus a minus 2b plus c into x and b minus c plus d as the constant number. Now comparing between the left hand side and right hand side, we can write that a plus c, since we don't have in the left hand side x power 3, so a plus c is equal to 0. And since I don't have in the left hand side term that has x squared, it means negative 2a plus b minus c plus d, it will be also 0. Now a minus 2b plus c times x, it is the coefficient of x, and we have negative 2 as a coefficient of x in the left hand side, so a minus 2b plus c is equal to negative 2, and the constant number b minus c plus d is equal to 4. So by solving the system, we can get that a, the value of a is equal to 2, the value of b is equal to 1, the value of c is equal to negative 1, and the value of d is equal to 1. So we can replace now to find the integration. The integration become 2x plus 1 over x squared plus 1 into dx minus 2 over x minus 1 into dx plus 1 over x minus 1 squared into dx. Here we can separate this fraction into two fractions. 2x over x squared plus 1 plus 1 over x squared plus 1 minus 2 over x minus 1 into dx plus 1 over x minus 1 squared into dx. We know that 2x is the derivative of x squared plus 1, so the integration of this fraction become ln x squared plus 1 inside absolute value. We know that we have a rule for the second fraction, 1 over x squared plus 1. It will be tangent, the integration of it equal the tangent minus 1 of x over 1, which is equal to x. Here, take 2 outside the integration. You can see that we have 1 over x minus 1, and it will be the ln of x minus 1 inside absolute value. The last one, we can use the substituting way, as we can take x minus 1 as u, so du is dx, so we can replace now 1 over x minus 1 squared by 1 over u squared, which can we rewrite it as u power negative 2 into du. So the integration of it equal u power negative 1 over negative 1. So it is equal to negative 1 over u. When we take u power negative 1 from the numerator into denominator, we will exchange the sign of the exponent. So we can replace u as x minus 1. So we have the integration of this fraction give us negative 1 over x minus 1 plus c.